Hello, welcome to the session on Design of Machine Elements 1. In this session, we will see what are the factors to be considered in machine design. We already have seen in the previous session that the steps in design, some of the terms such as mechanisms, force, stress, material, size, cost, manufacturing, etc. So all these parameters has to be understood properly. The factors which has to be considered in machine design can be listed as follows. That is, what device or mechanism to be used. This would decide the relative arrangement of the constituent elements. What is the material that has to be selected for each element? Then, what are the forces acting on each element? Then, the size, shape and space requirements. The final weight of the product is also a major concern. The method of manufacturing of the components and their assembly. Then, how will it operate? How the machine will operate? Then, the reliability and safety aspects. Then, the inspectability. Then, maintenance, cost and aesthetics of the designed product. These are the major factors to be considered in machine design. Now let us see this one by one. First we have this one, that is what device or mechanism to be used. This can be judged by understanding the problem thoroughly. Sometimes a particular function can be achieved by a number of means or by using different mechanisms, and the designer has to decide which one is most effective under the circumstances. So if we can make a rough design or a diagram of the whole arrangement, then the concept can be understood clearly and we can see the relative position of each element in the design. Next one, it is the material. Material selection is a very important aspect in the design process. A wrong choice of material may lead to failure, over or undersized product or expensive items. For example, if we select a brittle material when the nature of load is tensile, then the design will not give better result. So by understanding the suitable properties of the material for each component, we have to choose a material. And also we have to consider the fabrication or the manufacturing process, because we cannot apply all kind of manufacturing process to all materials, and the cost of the material and the manufacturing technology, that also must be considered. Next we have this load. The external loads causes internal stresses in the elements, and these stresses must be determined accurately, since this will be used in determining the component size. We have seen the example in the previous session. So the loading may be due to any of this reason, that is, one, the energy transmission by a machine member, dead weight, inertia forces, thermal effects, frictional forces. So I have taken this working of an internal combustion engine. This is a car engine. This also we have seen in the previous sessions. So here we are having different components, different elements arranged together to perform particular work. So the combustion of the gas is taking place inside this chamber, that is inside the cylinder, and the reciprocating motion of the piston is converted into rotary motion of the crank. So the energy transmission from one machine member to another machine member takes place. So that may be one reason for the load. Then the dead weight means the whole assembly can be considered as a weight. So that is a dead weight. Now the inertial force means we are having a component which is moving inside this cylinder. So that produces inertia forces. Now the thermal effects means here inside the cylinder the combustion of the gas is taking place and the combustion temperature will be very high, and during other strokes the temperature will be normal. So there is a variation in the temperature inside the cylinder, so which causes the thermal stresses inside the cylinder. So that is thermal effects. Then the frictional forces means you can see that the piston cylinder arrangement in this, the cylinder is actually, the piston is actually moving inside this cylinder. So there is a frictional force. So these are the loading types that is possible in any of this machine member. Now again, in other words, the load may be classified as static load and dynamic load. So first let us see the static load. The static load does not change in magnitude and direction and normally increases gradually to a steady value. So here we can see in the graph, the y-axis represents the load, the x-axis represents the time. It is a static load means it is gradually increasing and it is reaching a maximum value, and from there it is having a constant magnitude. So that is a static load. But in dynamic load, it changes in magnitude and also there is a change in direction. So the example for change in magnitude is if we consider the traffic of varying weight passing through a bridge. If you consider this bridge, different vehicles will be passing different time. So the load acting on this bridge, it will be different at different times. And it can also change in direction. That means if you consider a double acting piston, on both sides of the piston we are having the force acting on this. So that is the force's direction is changing. So we can represent this load versus time. The pattern you can see it is a zigzag pattern. It is not a smooth curve. So that is, it represents a dynamic loading condition. The three conditions are here. You can see this. It is having a zigzag pattern. It is not a smooth curve. Now the next parameter is the size, shape, space requirements and weight. By conducting preliminary analysis, we can get the appropriate size of the element. But if the standard element is to be chosen, the next larger size must be taken. The shapes of the standard elements are known, but for non-standard elements, shapes and space requirements must depend on available space in a particular machine assembly. Then, the material chosen for this must have required strength. That means the weight is important depending on application. For example, an aircraft must always be made light. So that means the material which we choose for an airplane, it should have a light weight, but at the same time the strength of this material should be high. So that is, and also if the equipment is portable, then it should be made using lighter material. Next, we have this manufacture. Care must always be taken to ensure that the designed elements may be manufactured with ease within the available facilities and at low cost. Next, it is how it will operate. At the final stage of the design, we must ensure that the machine can be operated with ease. As we know, many power operated machines, just pressing a knob or switch will start the machine, but in many of the machines a sequence of operations are required and it need to be specified, and this sequence must not be complicated and the operation should not require excessive force. Then we have this reliability and safety. This is an important factor in design. The machine which we design should work effectively and reliably. The probability that an element or a machine will not fail in use is called reliability. Reliability lies between 0 and 1. To make sure of this every details regarding, that is, whether there is a possibility of overloading or wear of the element or excessive heat generation, all this must be examined and must be avoided. Then the safety. Safety has become a matter of paramount importance these days in design. Industrial regulations, then it ensures that the manufacturer is liable for any damage or harm arising out of a defective product. Then we have this maintenance, cost and aesthetic. Good maintenance ensure good running condition of machinery. Often a regular maintenance schedule is maintained and a thorough checkup of moving and load part is carried out to avoid catastrophic failure. Low friction and wear is maintained by proper lubrication. As we know, in machines, this do have these parts which have relative motion with respect to each other, and this lead to friction and wear. High friction lead to loss of energy. We are and we have machine parts which have wear, and this wear of this machine parts lead to loss of materials and ultimately the failure of the parts. So this should be taken care of. Now the cost is related to the choice of the material, and the selection of the material is based on the stress developed in the component. The aesthetic considerations are not an essential aspect in machine design, but the ergonomic aspects can be taken into consideration. So in this session we have seen the factors to be considered in design. Thank you.